What is going on, guys? Welcome to your 38th chemistry tutorial, and in this tutorial I'm going to teach you guys how to balance an unbalanced chemical reaction, basically how we can determine the amount of molecules we end up with or the amount that we need for a chemical reaction, a nice balanced one, to take place. So let's go ahead and start with an easy example. Say I have tin, and yes, the chemical symbol for tin is SN. How they come up with that, I have no idea. But we have some tin dioxide, and we're going to go ahead and combine it with some hydrogen molecules. Now, whenever we do, we end up with tin alone and also some water molecules. So let's go ahead and balance this reaction and see where we went wrong. Well, let's go ahead and take a look at the tin first. SN, on the left side we have 1, and on the right side we have 1. Good to go. Now for the oxygen, let's go ahead and count these babies up. On the left hand side we have 2, and on the right hand side 1. Okay, something's wrong. So how can we go ahead and fix and balance this chemical reaction? I know, Bucky. I'm just going to go ahead and add a 2 right there. Bam. Next one. Well, you cannot do that. Don't ever touch the subscripts. Actually, if you can only remember one thing from this tutorial, it's don't ever mess with the subscripts in a chemical reaction. Now the reason for that is because first of all, it's invalid and it's against like the laws of physics, but aside from that, it changes the compound completely. H2O is water. H2O2 is not water. It's a different compound completely. So that's why you cannot ever touch the subscripts. You can't cut them in half, you can't add, you can't subtract from them. Just leave them alone. So you're saying, okay, so I have 2 oxygens over here and 1 over here. How am I supposed to fix that problem? Well, what you can do is you can fix the coefficient. You can change the amount of a molecule or compound that you make. So what we can do is we can go ahead and add a coefficient of 2, and all this would mean is whenever we took tin dioxide and combined it with hydrogen, we'd end up with 10 and 2 molecules of water instead of 1. So now we have 2 oxygens on each side. So the last thing we have to worry about is the hydrogen. So on the left hand side we have 2, and on the right hand side we have 4. 2 times 2 is 4. So you're saying, okay, now what am I supposed to do? Cut it in half again? No, all we have to do is go on the left hand side and say, okay, I have 2 hydrogens, so basically 4 hydrogen atoms total. So now I have 4 hydrogens on each side. This is a nice, even, balanced reaction. We got 1 tin, 2 oxygen atoms on each side, and also 4 hydrogen atoms. So again, why can we do this? Because we're not changing the chemical reaction itself, we're just changing the amount of products that gets produced or the amount of reactants needed to pretty much make that chemical reaction work. So let's go ahead and take a look at one more, a kind of more complicated example. So let's go ahead and say we have butane. Now butane is C4H10. Now before I continue, I just want to tell you guys this. You can't reduce that to like C2H5 because that would be a different compound altogether. Don't ever touch the subscripts. You can't. It's illegal. You'll go to jail. Don't do it. So if you take butane and you combine it with oxygen in the air, and by the way, butane is what you have in your lighters if you have a butane lighter. There you go. Nice little tidbit of information. Whenever you combine it with oxygen in the air, you end up with CO2, which is carbon dioxide, and also some water. You also end up with heat, and that's, why people buy lighters. But anyways, enough of that. So let's go ahead and take a look at this reaction, and we don't even have to write anything down to notice that something's not right here. We'll go ahead and we'll start with the carbons. Okay, so we have 4 carbons on the left, and I'm only seeing 1 on the right. Okay, I know how to fix this. Since I can't do that, we know that's illegal. Let's just go ahead and say we produce more carbon dioxide than we thought. Okay, fair enough. We don't change the chemicals or the compounds at all. It's illegal. So now let's go ahead and take a look at hydrogen. Okay, we have 10 hydrogens on this side and only 2 on this side. So how can we fix that? We just need to add a coefficient of 5 right there. So basically we end up with more crap than we thought, more carbon dioxide, more hydrogens, but the chemical reaction is still valid. 1 more to go. Oxygen. So we have 2 oxygen atoms on the left hand side, and on the right hand side after the reaction takes place, let's count them up. 4 times 2 is 8, plus 5 times 1 is 5, so we have 13. Remember, 8 plus 5, I'm pretty sure that equals 13. So now what we need to do is we need to figure out a way that we can take this, and how can we make 13 out of this? What can we multiply 2 by to get 13? Well, the answer is 6.5. Not 65, 6.5, just like that. So you're saying, Bucky, how the heck can you have 6.5 O2s? That really doesn't make sense. Well, it doesn't, and you can't have partial numbers or fractions of a number. So what we need to do is we need to round each one of these coefficients up to the nearest whole number. So in that case, what we need to do is we need to multiply all the coefficients by 2. And remember, the one rule that we have to follow: don't touch the subscripts. That's all we have to remember to make this valid. So we need to multiply all the coefficients by 2. And remember, if you don't have a coefficient that's written explicitly, we have to assume it's 1. So this would be 2C4H10 plus 6.5 times 2 is going to give you 13 O2 molecules. And we need to times the right hand side by 2 as well. So 8, that was a pretty bad looking 8, CO2, and 10 molecules of H2O. So that would basically be a nice, even, balanced chemical reaction. However, in some cases, you're going to see it like only this blue is written, because some of these things can get pretty big, and already you're seeing that this 2, 13, 8, and 10, these numbers are kind of in the way, because we know what happens whenever we combine butane with oxygen in the air. We get carbon dioxide and water. We don't really care how many molecules of each. So a lot of the times you're just going to see them written as blue. However, if you want to balance it out, what you need to do is you need to balance all the molecules and then find the right coefficients and then make the coefficients the smallest whole number possible. Pretty much simplify the equation. If you guys ever had math class, you know what that means. So that is basically how you balance an unbalanced reaction, and how you determine the amount of each molecule that you need either to start with or the amount of molecules that you end up with. So there you go, there you have it. I hope you enjoyed, hope you learned a little something. Thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next tutorial.